The Universal Tech Units podcast is an official tech podcast made by Speed and Nguyen, with the voice made from Google's Notebook LM. Do not reproduce our podcast without permissions from the owner.
Welcome to the Universal Tech Units podcast. Today, we have a challenge that is, well, it's really for the committed tech enthusiast out there. We're doing a deep dive into the Brunch framework. It's this complex, totally unsupported way to install full ChromeOS on regular PC hardware.
The kind Google never, ever intended it for.
Exactly. With the full Android app support, the Play Store, all of it.
And our mission for this deep dive is pulled right from the trenches. We're talking developer forums, XDA, Reddit. We're trying to give you a clear map through what is basically a technical minefield.
Synthesizing all those command line steps, compatibility checks, and the really critical troubleshooting you'll need.
Yeah, to actually pull this off.
Okay, so let's unpack this. Before we even get to the technical acrobatics, we need to understand why this is so difficult in the first place. It all comes down to what ChromeOS is. Exactly. I mean, ChromeOS is built on Gen 2 Linux. It's all about speed, security, and web apps, Gmail, Docs, Netflix. But that stability is built on these deep layers of defense.
Right, like verified boot and automatic updates.
And crucially, an A/B partitioning scheme.
And that security is key, right? They keep two complete versions of the firmware and the kernel right there, side by side.
That redundancy is what makes updating so seamless and safe, but it's also the very thing that makes installing it on a non-Chromebook so complex.
If you try to bypass that specific architecture, the whole OS just throws a fit.
It does.
Which brings us to the distinction that really drives this whole effort. We are not talking about Chromium OS.
Oh, no, definitely not. Chromium OS is the open source foundation. It's flexible, you get shell access, but it locks you out of all the proprietary goodies.
So no Google branding, no official DRM for Netflix.
And, crucially, no full Android app compatibility. I mean, the only reason people go through the pain of using Brunch is to get that full signed ChromeOS experience, Play Store and all, on their Dell or HP laptop.
So enter Brunch. How does this framework actually trick the official device-locked recovery image into running on my machine?
Brunch is it's essentially a translator and a patcher. It takes an official recovery image, one that's designed to only run on a specific Chromebook model, and it applies this really sophisticated set of changes.
Okay.
It injects a custom Linux kernel, and more specifically, an Anytramps.
Stop right there. For our listeners who might not be kernel hackers, what exactly is Anytramps doing here?
Think of it as a tiny little operating system that boots before the main kernel. It's a temporary environment, and its only job is to load the drivers that the official ChromeOS image doesn't know about.
For things like Wi-Fi or storage controllers on my random PC hardware.
Exactly. It also sets up this mandatory 1 GB ROTC partition, basically fooling the system into thinking it's running on approved hardware.
That is a clever hack for sure.
Yeah.
But the sources, they give a very real, very unsettling warning about the risk here.
Absolutely. Because you are using the OS completely outside its intended security perimeter, the risk is inherent. ChromeOS scripts are designed to operate in a very defined 12-partition environment.
So they can do unexpected things.
Developers explicitly warn that a standard ChromeOS script could, theoretically, just delete data on a non-ChromeOS partition by mistake. This is not a project for your daily driver machine with unbacked up data.
That warning gives me serious pause. Okay, but if you're still willing to take that leap, we need to make sure you aren't setting yourself up for guaranteed failure. Let's talk minimum hardware.
First, the basics. You need an x86-64 machine, full UEFI boot support, and at least say it's 16 gigs of dedicated storage. But the real gatekeeper here is the CPU.
It all comes down to the processor.
It's tied directly to the specific Linux kernel versions used in whatever recovery image you pick.
And this is where the complexity just spikes, because support isn't universal. You have to match your chip to a specific Google codename.
Precisely. For Intel, compatibility generally starts around the first-gen Core CPUs, but you need to know your CPU generation and the specific codename Google used for Chromebooks with that chip.
So for example,
for instance, 4th through 9th generation, Intel generally needs the Ramus recovery image. If you have a newer 10th gen chip, you're looking for Jinlin, and 11th gen and beyond often requires Voxel.
Wait, so I need to know my exact CPU generation and a code name just to pick the right starting file? That sounds like a huge barrier to entry.
It is. It really is. If you pick the wrong base image, the custom kernel that Brunch injects It won't detect your graphics, your touchpad, anything critical.
And for AMD users.
It's even trickier. It's mainly Ryzen chips, which is codenamed Gumbos, and some of the older Stony Ridge or Grunt chips that are supported.
And so if you have an older AMD or an Intel Core 2 Duo or an NVIDIA GPU...
But consensus is, just save your time. It's likely unsupported, and virtual machines are completely out of the question.
So once we've found our CPU family and its matching recovery image, how do we pick the OS version? The sources list 4 build types.
Right, you pick based on your risk tolerance. For the average user who just wants stability and the Play Store, you want the stable builds.
Recommended for daily use.
For sure. Beta builds are also a good choice stable, but with more recent features.
And then we get into the deep end for the more experimental users.
Yeah, the Dev and Canary builds, these are highly buggy. They're only for power users or developers who are testing things out. Definitely not recommended for a daily driver.
And the most important thing.
No matter which one you pick, you absolutely have to match the Brunch framework version to the ChromeOS recovery version you downloaded. It minimizes errors, crashes, all that stuff.
Okay, now for the central installation challenge. How do we get this custom OS integrated into a system that already exists? Why can't we just, shrink the Windows partition and install it next to it?
Because of that security architecture we mentioned, ChromeOS demands its own proprietary 12-partition GPT disk layout.
Partitions for kernel AB, roofs AB, state.
All of it. Trying to install that natively would almost certainly wipe your existing boot sectors and partitions. It's a landmine.
So we use a clever workaround. It keeps the whole OS inside a single file. This is where the developer community really shines.
It really does. It's called the disk image and GRUB2 loopback method. So think of it this way. Instead of a traditional partition, you're creating a kind of digital CD-ROM image.
A big .img file.
A monolithic .img file, yeah. And it just sits harmlessly on a standard partition like NTFS or XT4. The trick is that the GRUB bootloader has to use a special instruction, the loopback command, to trick the system into mounting that file as if it were a real physical disk.
With all 12 of those required partitions inside.
Exactly.
Okay, let's break down the installation summary then. 4 conceptual steps to get that image made and integrated.
Step 1, environment setup. You need to be in a Linux environment. It can be native or Windows subsystem for Linux 2, WSL2, or even Nguyen. Because the core tools, specifically CGPT, the GUID partition table utility, are Linux utilities. They won't run in a standard Windows command shell.
Step 2, partitioning.
Simple enough. You identify or create a dedicated, unencrypted partition. XT4 is recommended, and it needs to be big enough for the image file, so minimum 16 gigs free.
Step 3, image creation. This is the main event.
You run the crucial script, chromeos-install.esh. This takes your recovery image, it patches it with the Brunch kernel, and then it generates that big chromeos.mng file on your partition.
And it also gives you something else, right?
Critically, yeah. It spits out the exact multi-line GRUB configuration block you're going to need.
And that leads to the final step, bootloader integration.
You manually take that configuration entry, the one with the loopback loop chromeos.mng command, and you paste it into your system's boot configuration file. Then you update GRUB, and the system should see it on the next boot.
One last hurdle.
Oh, right. Secure boot. It usually needs to be disabled. Or you have to enroll the Brunch security key. It's a file called brunch.rdir using the mochatil import command. That key is what allows the custom kernel to run.
So we've navigated the installation, but as the source material makes really clear, the complexity does not end there. The forums are just filled with people who followed all those steps perfectly.
And then get stuck.
At the single most frustrating failure point.
Yeah.
Booting from the internal drive via GRUB.
Yes. The system boots, you pick your new ChromeOS entry, and then it just freezes. Dead. At loading Brunch framework, no error message, just a complete halt. It makes you question everything you just did.
But the sources, they reveal this crucial, almost magical piece of diagnostic info that isolates the problem. What is the key clue?
The key insight is this. The user takes the exact same chromeos.mng file, flashes it onto a simple USB stick with a tool like Rufus, and it boots perfectly.
That's the smoking gun.
It is. It tells you the image is good, the framework is working, the hardware is supported. The problem is pinpointed solely to the GRUB loopback loading procedure on the internal drive.
So the failure isn't in the OS itself, it's in the communication layer, GRUB, failing to properly load that giant image file from the internal file system.
Exactly. When that happens, you have to focus on the GRUB variables. Did you correctly specify the UUID of the partition where the .img file is? Did you type the file path correctly? I mean, I know developers who have spent a day debugging a system because they mistyped one digit in the UUID.
So double check every single character.
Everyone.
What are some of the deeper workarounds when the path and UEID look right, but it still fails?
Sometimes it's the EFI boot path itself.
Oh.
If the USB stick boots, you might need to manually inspect the EFI path it used. The community advice is often to just copy the entire working EFI content from the USB, stick to your internal EFI folder.
And then manually select it in the BIOS.
Right. Go into your BIOS and manually select boot from file to bypass any stubborn internal logic. Also, if you're on Linux, make sure your GRUB menu is actually showing up. You might need to edit etc default grub and change grub timeout style to menu and give yourself a longer timeout, like 30 seconds.
That is a lot of manual configuration just to get past the splash screen.
Yeah.
So once you actually get it running, how fragile is the system when it comes to updates?
It's the ultimate tightrope walk. Updates are a huge source of breakage. ChromeOS is designed to update itself automatically, but when it does, it's expecting its own partitions and its own kernel.
Not our custom Brunch kernel.
Exactly. If the official update runs without you updating the Brunch framework first, you risk immediate instability, lost Android compatibility, or the dreaded unexpected power wash.
Which wipes all your local user data.
Yep, gone.
So the user has to become their own manual relief manager just to stay current.
They do. The safest strategy is sequential and manual. You update the Brunch framework archive first, then you use a cross-shell command to manually update the OS image, making sure the versions are compatible. You can enable the Enable Updates option for native updates, but you're essentially just betting that the next official Google update won't break your entire system.
It's a real power user commitment.
It really is. So what we've established is that the Brunch framework, it offers this powerful reward, right? You unlock full ChromeOS features, Android, the Play Store, on your custom hardware, but that power comes with continuous, intense responsibility.
Manual kernel management, precise GRUB configuration, and navigating these extremely precarious update paths. And it certainly raises an important question for anyone even thinking about this. Given all the instability, the constant need to troubleshoot that loopback process, the risk of updates wiping your data, how should you weigh the benefit of this full Brunch experience against the simplicity of just using ChromeOS Flex?
Right, Flex is officially supported.
It avoids all these deep configuration challenges, but it lacks those core Android features. So is the Play Store worth becoming your own full-time system administrator?
That is the ultimate trade-off, isn't it? Features versus stability.
See you again in the next episode of This Tech Podcast.